Okay, right at the top, you should write graphing acceleration notes. Let's go ahead and get started a little bit. Some of this is going to be refresher, or a little bit of review about graphing velocity, but then now we're going to graph acceleration, which we learned last week. Okay, we're only going to learn about bits and pieces of the graph. If you were to Google this, you're going to find other pieces of the graph which I don't talk about in this class. So I really recommend you don't Google this stuff. If you get lost, you're welcome to ask questions. What I have a little bit of concern on is that a lot of people aren't starting the homework until Thursday, and then they take the quiz on Friday and not do so hot. If you start the homework on Monday and ask me questions throughout the week, then you tend to do better. It is almost eerily similar. The score people get on a homework is pretty much the score they get on the quiz. So, if you don't prepare on the homework, you're probably not going to do well on the quiz. I'm going to say probably, I can't speak for certain, but probably. Okay? So let's go ahead and get some written down. Okay? Okay. What I want you to unpack is a position versus time graph. There's another way we can write it though. So if I was in your shoes, what would I be writing? Well, I'd be writing this graph, but I wouldn't write it verbatim or exactly. Let's do a different color. Let's do red. I would draw this graph, this line, and position, which is also displacement, and time, which is t. So if I was in your shoes, I would paraphrase what's up at the top and just draw the red marker as the graph of what we've done. Cooper, you got a question?
No.
Just stretching. Okay. We do this quite a bit, but some people still struggle with it, which is why I'm bringing it up again. Okay. We're going to talk about 3 different graphs by the end of the day today. This is the first of the 3. Okay. It is a displacement versus time graph. So I'm going to backtrack just a little bit. Whenever you talk about graph, it's always y versus x. Meaning whatever is your y variable versus your x. So if we're looking at this graph, this is displacement versus time, where displacement is your y and time is your x. First shot I can do today. Actually, I'm gonna hold out for pause. Once people write some stuff down. Owen's pondering what question I'm going to ask so we can figure out and get a first piece of candy for today. Do you know what question I'm going to ask?
The answer is 42.
Answer is 42. No, but that is, I would say, ironically, the answer to life. What? It's a movie reference. Well, technically a book reference. Oh, I'll give you a piece of candy if you know what reference it's from. Hitchhiker's Guide to the Galaxy.
Who's that?
The robot's name is Marvin, right? Yeah. It's good. So, in a displacement versus time graph, okay? Well, let's unpack this a little bit. We're going to look at slope. What letter do we use to represent slope? Just generically in like math class. I'm going to hold off Brock for the harder questions later today. But other than Brock, help me out. Hey, what is it?
L.
Not L. I don't know why they choose this letter, but it is a weird letter. Taylor, what is it?
M.
M. Nice shot, Aiden, though. Do you remember what slope is, though? How do you calculate it?
I feel like it has something.
Percival? I don't know. Maybe figure out later. Help me out. Taylor, how do you calculate slope?
Isn't it like change over?
Yeah, let's go with like the super simple like math one though. Like in math class, like middle school, they teach slope is blank over blank. What is it? It's alright, Kai's so willing to help you out. Kai, what is it? Absolutely. That is like the full complicated definition. I want like the super simple one. Super simple. It's like I asked you like write me a paragraph, you've written me a book. Okay, you're just going way forward on me. Hey, what am I looking for? Rise over run. Which is also the y2 minus y1, x2 minus x1. Okay? So when we look at the graph, we look at the slope, which is rise over run. Another way to write that is change in y over change in x, which is where the y2 minus y1, x2 minus x2 minus x1 comes from. Okay. Well, let's look at this. In a distance versus or displacement versus time graph, what's my rise and what's my run? Ava, you ready? Coming in hot. What's my rise and what's my run? What variables on the y-axis, Katie? Displacement, right?
Displacement is rise and then time is rise.
Absolutely. So what we get to is that it turns into displacement over time, which is
Rise over run.
rise over run. What is displacement over time?
Change in,
We learned it like 3 weeks ago. It's the pink poster.
change in,
Devin's the one to help you out. Devin, can you alley-oop it? Can you slam dunk it? Velocity, absolutely. So the slope
is the reason.
in a displacement versus time graph tells you velocity. Okay? For the sake of time, I'm not going to go through examples I'd like to go through here. I want you to be comfortable with, and I think a large majority of you are, positive, negative, and zero slope. So what we could say is that right here, the velocity is positive because the slope is positive. Here we'd say velocity is 0 because the slope is 0. A lot of you have done a really, really good job of pointing that out. But then the next step in our brain is, what does positive velocity mean? It means you're going to the right. Zero velocity means you're not moving. Okay? Alright, any questions here? Hopefully that was all refresher. Because now we're going to change the graph. Instead of a displacement versus time graph, we're now going to do a velocity versus time graph. Alright? So this graph is different. Different how? No. It's still a graph. We have time on the x, but we have velocity on the y. And here is, let's do that a little bit better. There's our line. And so when you look at a graph, it's always going to be y versus x. So for this instance, it's going to be velocity versus time. I'm going to go back to what I had earlier. Slope is rise over run. So now let's unlock the next piece. I'll give you a second to think about what could the slope here represent. It's on the slide. What is my rise and what is my run? What's my y and my x? It's going to be what over what? What do you got for me, Taylor? 4 over 1. I am not looking for numbers yet. We're talking about just variables. But we will talk about numbers in a second. So let's put pause on that. We're looking at just units. What is the units for my rise? It's velocity, right? Oh, let me try that again. Where's my undo button? Let me erase that. We got velocity over, what's my run? Time. Now, what in the world did we just learn last week was a change in velocity over time? It's on the orange poster. See the V over T? Which is change in velocity equals what? Acceleration. So, I'm going to bounce back and forth real quick. So, when we look at a displacement versus time graph, the slope tells us velocity. When we look at a velocity versus time graph, the slope tells us acceleration. So you can also look at this as change in velocity over change in time, but I'm not going to go there just because I think that's a little confusing. But, okay? So from there, we can determine the acceleration of the object. You ready, Taylor? I did a pretty good job kicking earlier, so I'm going to try kicking one more. First period of the day, looking great. It's only going to go downhill from here. There's no way I'm going to kick better than that. Okay, now let's actually calculate the slope of this line and calculate. Let's get a number for acceleration. So what is my rise and what is my run? Brock, can you help me on that? What's my rise? You can go up 4, sure. 4 meters per second. And what's my run? 1. You chose that little first part right there. That works totally fine. Since it's a straight line, the slope's always the same. So we chose 4 and 1. You go up 4 over 1. What's 4 divided by 1? 4 divided by 1, Brock. Whew, hard stuff. But what's the units for acceleration? Meters per second squared. That's because you got meters per second divided by seconds turns into meters per second squared. Ready, Brock? Go behind the back. Gotta warm up like Donkey Kong. Go to the Phantom student. That's right, you don't even want it. Why are you even giving candy? He always gives it to somebody else.
Yeah, Brock, there's a problem.
Okay. There's no really new material from last week to this week. It's only taking acceleration and applying it to a graph. Okay? Any questions here? Okay. I'm going to put a pause on this, and I'm going to go to here first. All right? What I write on this board is going to be a nice summation of everything we've done. So if I was in your shoes, I would absolutely write this part down. We have a displacement versus time, velocity versus time. If we were to big brain it, what's the third type of graph we could probably do? What is it, right? Acceleration versus time. Look at that. It's up there on the board. Acceleration versus time. How do we pick out our pieces of information? So if I was in your shoes, this is a little chunk I would reference when I'm doing the homework this week, okay? Because it'll help you the most, okay? These instances are not the same, but
You switched the period.
let's do when it comes to a displacement versus time graph, what does the y value tell you? Kev, you ready? Let's try it out, man. Are you good the y's this way? Next this way. Okay. Just want to know how much your brain's turned on today. So looking at this displacement versus time graph, what's the y value going to tell you? Close, the other one, Not distance, but displacement, absolutely. So the y value tells you displacement. Remember what slope will tell you? We just went over it. Sorry. What will the slope of a displacement versus time graph tell you? We just did it. We just did it. We just did it. Ruby's like, that one's gonna be rise over run. In this graph, what will the slope tell you then? D over T, which is velocity. Cool. Grab some chocolate. Alright. Try kick. So there's me a short kick. Is either gonna go disastrously wrong or right on the money.
Or it's gonna smack you in the face.
Okay. So in a displacement versus time graph, so displacement versus time, the y value tells your displacement, the slope tells your velocity. What about a velocity versus time graph? What's the y value going to tell you? Ruby. Ready, Rube? You get that this is y and this is x? So if I look at my y values, what does it tell me? Velocity, fantastic. Come on. I don't know why it does that. I do know why it does that. I just don't like it. What does the slope tell me? Sorry, we just learned it like 30 seconds ago. What'd you give me slope is? Rise over run, right? Well, that would be velocity over time. What did we learn last week was change in velocity over time? Acceleration, absolutely. So the slope of a velocity versus time graph. I'll put lines down here. Gotta make sure we're separating them. Now I'm not making this one up. I'm not truly gonna say this. Okay. I just think this one's funny. If you really paid attention to the reading last week, you'll know what the slope of acceleration versus time graph tells you. We will never calculate it. I just think it's a funny word. Ready, Rube? You interested, Dum Dum? No? Sorry. What's the y value gonna tell you? What's gonna be on? Parents, that your Chromebook's more important than class today. Brandon,
Please.
y value for acceleration versus time graph. What's it gonna tell you? I'll give you a hint. Ready? In a displacement versus time graph, the y value is displacement. In a velocity versus time graph, the y value is velocity. So in acceleration versus time graph, the y value is going to be acceleration. There you go. Okay. Now, there's not going to be ever an instance where you have to calculate the change of acceleration, but I just think it's a funny word. Does anyone remember what that funny word is from the reading last week? Jerk. So the change in acceleration over time is called jerk. If we ever do a project again, at some point might do egg drops. What's the part that actually breaks your egg? Is the jerk upon the egg. So here's what you should be able to do, since I'm running a little bit out of time. Okay. Can I go back? Everybody, people start writing this down. Can I go here? Can I be here? I got nobody immediately protesting. Describe what the object is doing quantitatively and qualitatively, meaning with and without numbers. Layla, how you doing? You weren't here last week, so I can't really call on you. That's a bummer. Can you help me out though with slopes? Are you good on slopes? No? Like positive, negative, and zero slope? Can you do that? Okay. So if you look at this first little chunk of the graph, you can tell me that's what kind of slope? Positive, absolutely. This next little chunk would be staying the same. So there's nothing different. What's the mathematical term for nothing? Nothing? Zero, fantastic. So we got a positive slope, we got a zero slope, and then what's this slope going to be? Negative, and then we're going to go positive again. So what's this mean? We had a positive acceleration, we're speeding up to the right, or up if we're on a jetpack. Constant acceleration, negative acceleration, positive acceleration. Okay.
That's too large for the fit.
Okay. You want it? You sure? Positive? You don't look excited. Joel, you ready? I got a few minutes. Let's see if we can squeeze it in there. No numbers. Alright? I want answers come from your brain. If positive acceleration is speeding up to the right, and negative acceleration is speeding up to the left, what in the heck does a zero slope mean?
It's standing.
Absolutely. What's the keywords we would throw in there? I'm looking for like two keywords from like last week's lab. One starts with a C.
Constant speed.
Other starts with a V.
Constant velocity.
Constant velocity, because velocity tells you direction. Joe Neal. I'm gonna say that's like Snickers worthy. You hear that? Okay, so if your slope is zero, you're going a constant velocity. You're going the same speed and direction at the same time. Okay? Alright, what we got is for tomorrow,